How to fix Rust disconnected error with disk. Welcome back to Teknobalta. Technical overviews. During our recent lab investigations, Teknobalta engineers identified a critical network conflict occurring when players attempt to run Rust alongside Discord. Our analysis revealed that utilizing deep packet inspection bypass tools creates severe routing collisions with easy anti-cheat and Rust's server architecture. When these packets collide, the network stack essentially forces an exclusive connection, causing either the game or the communication platform to completely drop internet access. We have thoroughly tested and verified the following comprehensive solutions to permanently eliminate this disconnection error. Step 1. Complete removal of DPI bypass services. Our primary testing showed that running tools like Goodbye DPI while gaming creates a bottleneck in the network adapter's packet routing protocols. We discovered that depending on your specific internet service provider, these bypass tools are often entirely unnecessary and actively disrupt game server handshakes. To fix this, you must completely uninstall the DPI bypass tool and verify that its background services are no longer running in the Windows Task Manager. Step 2. Implementing a custom DNS configuration. After removing the conflicting DPI software, our diagnostics indicated that a robust domain name system configuration is required to restore Discord connectivity. We recommend navigating to your network adapter settings and manually assigning high-performance DNS addresses like Cloudflare or Google. Changing your primary DNS to 1, 1, 1, 1 and secondary to 1, 0, 0, 1 successfully bypassed the initial connection block during our network stress tests. Step 3. Utilizing advanced routing with split wire sock. If standard DNS adjustments fail to restore your communication channels, Teknobalta's research points to split wire sock as a superior routing alternative. This tool allows for highly targeted application routing, bypassing restrictions without manipulating the entire operating system's network traffic. Implementing this specific bypass method resolved the mutual exclusion error between the game and the voice client in our controlled environment. Step 4. Flushing the DNS resolver cache. Lingering corrupted cache data from previous DPI bypass attempts will continue to trigger server timeouts in Rust. To clear this residual data, open the command prompt as an administrator and execute the IP configuration flush command. Typing ipconfig/flushdins instantly clears the local resolver cache, forcing both applications to establish fresh, untainted server handshakes. Step 5. Resetting the TCP/IP network stack. Deep network inspection tools frequently leave behind modified WinSock catalog entries that disrupt easy anti-cheat protocols. Our technical team resolved this by initiating a complete TCP/IP stack reset through the elevated command prompt. Simply type netch winsock reset followed by netch int IP reset, and then restart your computer to apply a clean network baseline. Step 6. Disabling Discord quality of service packet high priority. Teknobalta engineers discovered that Discord's quality of service feature aggressively flags voice packets, which modern routers occasionally misinterpret as a localized denial of service attack when paired with Rust's high tick rate data. Navigate to your Discord voice and video settings to locate the quality of service toggle. Disabling the high packet priority option immediately prevents the router from dropping the game's essential server traffic. Step 7. Reconfiguring the Discord voice subsystem. During our exhaustive hardware compatibility tests, we noted that the standard Discord voice subsystem struggles to maintain concurrent connections under heavy anti-cheat monitoring. Changing the audio subsystem from standard to legacy forces the application to utilize a simplified audio routing protocol. This adjustment significantly reduces the network overhead and prevents the disconnected error when joining a game server. Step 8. Adjusting easy anti-cheat processor priority. Resource allocation conflicts often manifest as network drops because the anti-cheat engine cannot process incoming server packets fast enough. Open your Windows Task Manager, locate the Easy Anti-Cheat executable within the Details tab, and elevate its priority to high. This ensures that the security module receives the necessary processing cycles to authenticate your session without interrupting background communication applications. Step 9. Disabling IP6 on the active network adapter. Our network traffic analysis highlighted that Rust servers predominantly optimize for IP4, and dual-stack configurations can lead to routing confusion when bypassing restrictions. Access your network connections, open the properties of your active adapter, and uncheck the Internet Protocol version 6 box. Forcing all traffic through the IP4 protocol creates a highly stable, singular network path for both applications. Step 10. Verifying Rust game installation integrity. Corrupted network configuration files within the game directory can falsely trigger anti-cheat disconnection protocols. Open your Steam library, right-click on the game, and utilize the built-in file verification tool within the Installed Files menu. Our lab testing confirmed that redownloading missing or corrupted network manifest files instantly stabilizes the connection to community servers. Step 11. Configuring inbound Windows Defender firewall exceptions. Overly aggressive firewall rules frequently block the background ports required for seamless voice communication, while a full-screen application is actively transmitting data. You must manually add both the game executable and the Discord application to the allowed apps list within the Windows Defender firewall settings. Ensuring both public and private network permissions are checked guarantees that packet traffic flows without strict interception. Step 12. Updating the network interface controller drivers. Outdated network adapter drivers possess legacy bugs that fail to handle modern asynchronous UDP traffic generated by simultaneous gaming and voice streaming. Navigate to your motherboard manufacturer's website to download and install the absolute latest network interface controller drivers. Teknobalta testing proves that updated drivers optimize buffer management and prevent packet dropping under heavy load. Step 13. Optimizing router maximum transmission unit size. An incorrectly sized maximum transmission unit causes packet fragmentation, which severely impacts latency-sensitive applications trying to share a connection. We recommend logging into your router's administrative dashboard and adjusting the MTU value to a stable baseline of 1492 or 1500. This precise calibration prevents the network node from splitting packets, ensuring that both programs maintain their connection integrity. Step 14. Disabling background network telemetry. Windows utilizes background telemetry that consumes crucial bandwidth and creates microstutters in the network routing table. Using the Group Policy Editor or Registry Editor to disable connected user experiences and telemetry frees up the routing queue. This streamlined environment allows your primary applications to negotiate server handshakes without interference from operating system data collection. Step 15. Reevaluating ISP routing restrictions. Our final investigation phase revealed that certain internet service providers dynamically route traffic through congested nodes, artificially replicating DPI blocking behaviors. Contacting your provider to request a static IP address or a profile shift to a gaming-optimized routing path eliminates these artificial bottlenecks. This foundational network adjustment permanently resolves the underlying conflict between your game and communication platforms. Don't forget to follow Teknobalta for more.